All right, so today we're going to use some properties of logarithms that you don't know yet, but you will, to manipulate logarithmic expressions. And so the properties of logarithms are very related to the properties of exponents. So there is a product property for logarithms. And so if you have the logarithm of two factors that are multiplied by each other, then you can separate those factors using addition. So whenever you're separating, each different factor gets its own logarithm. All right, so that's kind of like the product property for exponents. So if you're multiplying with the same base, what do you do with the exponents? You add. So multiplication and addition are going to go together with logarithms just like they do with exponents. Now, most of the time, I would say 75% of the time, we want to go backwards with this property. So we have two logarithms separated by addition. We want to bring them together as one logarithm using multiplication. That is way more helpful in the grand scheme of things with logarithms than the other way, but we do need to know both ways. All right, there's also a quotient property for logarithms, similar to the quotient property for exponents. So if you have logarithm of a quotient, you can separate it into multiple logarithms that are subtracted from each other. And again, it is more useful to go the other way to bring them together using one logarithm. All right, and then the final property is the power property. And so it's similar to with exponents. When you have a power raised to a power, you multiply those together. So when you have a logarithm of a power, you can take it and multiply by it in the front. Or if there is a number multiplied in the front, you can move it up to a logarithm to use the property in reverse. All right, so let's do some examples. So this first is a lot of examples. It's A through H that we're condensing them to one logarithm. So when we condense to one logarithm, it's going to be 1 log base 4. And then these logarithms are separated by addition, so what do you think we're going to use to bring them together as one logarithm? Multiplication. So it would be log base 4 of x times y. All right, and then for B, we have two logarithms separated by subtraction. So we're going to bring it together as one logarithm. And then because they're separated by subtraction, what are we going to do with the 5 and the z? We're going to divide. Right, and then the majority of the time, you do have more than two logarithms, or it feels like the majority of the time. And so sometimes you have a combination of addition and subtraction. So we'll have a combination of multiplication and division on these. But we're going to have one logarithm, so 1 log base 10. And the way I think about this, you can kind of think about a subtraction sign like a negative exponent. And so if you guys remember, negative exponents bump things down in the denominator. It's kind of the same idea. So if there's subtraction anywhere between your logarithms, there is for sure going to be a fraction bar. And then what I think is, if it is positive in front of the logarithm, that argument, which is the x part, is going to go in the numerator. And then if there is subtraction in front of the logarithm, that argument, or the 5 and the z, they're going to go in the denominator, and they'll be multiplied in the denominator. You won't have addition or subtraction between them in the denominator. It's multiplication. So positive, you get multiplied in the numerator. Negative, you get multiplied in the denominator. All right, so look through those before we add the final property, the power property. Not power property. There's a whole bunch of P's. In my calculus class, there's a whole bunch of R's today, so I'm going to be tongue-tied all day today, I'm pretty sure. All right, so let's talk about the power property. If there's a number in the front and we're wanting to condense, what we need to do is bring that number up to a power, or an exponent. Now, this is the first time you guys are doing this. Probably by the time we're finished with this lesson, or maybe even now, I don't know, you might be able to kind of skip this step and just go straight to the answer. But it's okay. We can write a lot in our notes. It's good. Okay. And then I want to write this as one logarithm. So we have a 1 log base 2. And then because these are separated by subtraction, I'm going to bring them together using division. And whichever logarithm has a negative in the front, that argument goes in the denominator. All right, so E is kind of tricky, but I do want you to try it by yourself. And if you mess it up, it's okay. You have an eraser, or if you have a pen, you can mark it out and fix it. All right, so I see that there is a subtraction sign. So I know for sure I'm going to have a fraction bar. So the a squared, is that going to go in the numerator or denominator? Numerator. What about b to the 5th? Denominator. All right, so what does it mean to raise something to the 1/2? Square root. Good, you guys answered that really fast. All right, so what is 4 to the 1/2? 2, and where does it go? In front of the a. Good job. All right, so if you mess something up, it's okay. You can fix it. All right, so there are a few on this notes and on your assignment that really kind of make you think. They're not super straightforward. And I feel like F is one of those ones that you kind of have to think about to get it. So we want to write this as a single logarithm. But 2 right now is not a logarithm, it's just a number. So we want to somehow figure out a way to represent 2 using log base 6. So log base 6 of something is going to be 2. So think about that for a second. We haven't really talked about what a logarithm means in a while, since before we had a little snow break. Not reciprocal. All right, so we want log base 6 of something to equal 2. So what do you guys think? Anybody have an idea? Did have. It's 36. So it would be 6 to 2 equals that something, which is 36. So 2 is equal to log base 6 of 36. All right, and then I need to bring those together. What am I going to use to bring them together? Multiplication. All right, and so I feel like A through F is something that you'll probably see on the multiple choice of your test for me and for the AP test. But on the free response, number 4, there's probably going to be 2 logarithm questions. One of them you're just going to write as a single logarithm. And then another one, you're going to solve a logarithmic equation where you'll have to still use these same properties. And on those, on the free response, you aren't going to have like X and Y or A, B, and C or whatever. you're just going to have x. So I want to practice some of this. So I added these to Brian Passwater's notes, and I put some on your assignment just so you can practice that a little bit more. But it's the same concept at the beginning. So before I can bring these together as a single logarithm, what do I need to do first?
Separate. Center one around. Power property.
Yes. So the 6 needs to come up. I see what you're saying. We don't want to separate. That does make sense. I can see why you would think that. But we're bringing them together. So really, I just would start off by moving that 6 up to an exponent. And then I'm ready to write one logarithm. Since there's subtraction, I do know I'm going to have division. All right, so you guys put the things where you think they need to go, please. All right, so on the ones we've been doing, at this point we were finished, but on this one we're not. We can simplify this more by by multiplying and then combining the x's, simplifying I guess is a better word. So I would multiply the numerator and get 18x to the 9th. All right, and then I would keep simplifying. So what should my final argument be? Very good. So these two, you would subtract those exponents, and you'd end up with 18x to the 3rd. So there's a couple extra steps on that one. So for your response, I would expect there maybe to be a couple extra steps, but not necessarily. All right, so let's look at this last one. So again, this is something you might see on the free response question number 4. And then same thing, I do need to move that 5 up to an exponent. Okay, so if there's positive in the front, I do want to put that part in the numerator. And negative, I want to put it in the denominator. Now last class, I put the 8 here, and it's fine, it's right, but I didn't like the way it looked because it almost looked like it might be an exponent. So I'm going to go ahead and put the 8 in the front. It is right in the back. It is correct in the back. But it just depends on how messy you write that. It might look like an exponent, so let's just put it in the front for now. All right, now this one we're done. So the difference between these two is these x's weren't bound to anything, so we could multiply them together and add the exponents, and then we could simplify them. These x's are bound, and so we're done. The only thing you could possibly do that I think is unnecessary is multiply 3 by 8. That's not going to help anything, so I would just leave it. All right, so what questions do you guys have? Okay, so we do need to practice some doing it the other way, where it is a single logarithm and we separate it out to multiple logarithms. On those, each different variable or even a constant, each different factor, I guess, gets its own logarithm. So x is going to get a logarithm and y is going to get a logarithm. And so they're both going to be log base 3. What should go in between the logarithms? In this case, subtraction. Very good. All right, and then that doesn't look like any of the answer choices. So on this one, when we're separating, if it is a power, we're going to want to move it down in the front. So that's choice C. All right, And we do have one more property to talk about. It's the change of base property. Now, when I first started teaching, the graphing calculators didn't have the log base function. They've been updated in the last 26 years. So we would do the only options we had on the calculator were natural log and common log. And so if we wanted to find log base 2 of 10 or whatever, we would have to use this property, and we could type it in the calculator and find it. And then the calculator's updated, and I kind of quit teaching this property. And then I saw it on the ACT, so I started teaching it again. And it's probably going to be on the AP exam also. If it is on the ACT, you can get it right in 1 second if you just know the property. So if you want to change the base to something else, you can change it to any base you want to. What you do in the numerator is log and then whatever base you want of the argument, and then divided by log of that same base of the original base, and it will give you an answer. And that's how we used to be able to find some, like log base 2 of 9. That's what we used to have to do. But on the ACT, the ACT is written in a way that you can do every single math problem without a calculator. So it's nice if you have one because it saves you time, but every single problem can be done without a calculator. And this is one that they like to put on there. And so you would have log base 3 of x, and it would say like which answer choice is equivalent to it. And in this case, if we wanted to do common logs, it would be log of x over log of 3. And then if you wanted to do natural logs, it would be natural log of x over natural log of 3. Now, like I said, you can change to any base you want to. Those were the ones we would always use because that's what you could do in the calculator. All right, so you guys try B on your own, please. All right, any questions on that? So the ACT is coming up in February. There's always a logarithm question or two on there. The one I've seen in the past, like, it's kind of late for you guys, for me to be telling you this, but you can buy your ACT test in December. You might be able to buy it in June too. There's a couple of times that you can actually buy the test and get your answers and the right answers. And that's how I saw it, because I did that for my kids. I bought their test and then I saw some questions. Okay, and then for example 4. This one is it's a challenging question. So we know that f is log base 4 of x, and we know g is log base 9 of x. We want to show that f is a vertical dilation by finding the value k such that we could take k, multiply it by g, and it gives you f. All right, so this is what I'm going to do. I know f of x is log base 4 of x, so that is that. We want to change it so it is similar to g, which is log base 9 of x. So I want to change the base to 9. So you guys use the change of base formula for me, please, and change the base, change this to log base 9. So it would be log base 9 of x over log base 9 of 4. All right, and so we want to change this. So f of x is equal to some constant times g of x, which is log base 9 of x. So what would you multiply this by to get this whole thing? Nobody figured this out in my last class. You want to be able to multiply log base 9 of x by something to get this whole
Be
thing.
the negative log 4.
Yeah, I think you're thinking right, but you're thinking harder than it has to be. So it's just going to be 1 over log base 9 of 4. So that's what k is. Nice job. Okay, so it's a little challenging. It's asked in a weird way.